Everybody, happy Thanksgiving. Welcome to the first video of Unit 5 on integer exponents. We're going to multiply and use exponents. You can see our goals are down below. Make sure you're taking notes as you do this. Let's say that we have this expression here. The way we would say that would be 2 to the 4th power. This thing is called a power in general. The base is the bigger number. What's the base of this? 2. That tells me what is being multiplied. I am multiplying 2. The exponent is the small number. What is my exponent? 4. That tells me how many times to multiply. I am multiplying the base, what? I'm multiplying 2 4 times. So 2 to the 4th power could be written as 2 times 2 times 2 times 2. I was multiplying my base 4 times. If you have a variable base, you'd say x to the 2nd power. Some of these have special names, like x squared or x cubed. But in general, you could say any of these exponents as the base to whatever exponent power. This expression is x to the 4th power. Sometimes you'll see people refer to powers, like powers of 2, powers of 3. That's another name for an exponent. Sometimes they refer to the entire thing as just a power. So an exponent and a base together could be a power. So for example, 3 to the 7th could be a power. Write these as repeated multiplication and simplify completely. So you see I have 3 to the 5th power, 3 to the 2nd power. Well, 3 is what I'm multiplying. That's my base. My exponent is how many times. So in the first power, I have 3 to the 5th power. So I could write 3 multiplied by itself 5 times. Okay, that's the first one right here. That's my blue stuff. I'll do the other one in red. That's 3 to the 2nd power. 3 times 3. And when I have two parentheses right next to each other like this, that implies that I am multiplying those. So I'm multiplying the red ones by the blue ones, like so. Now, how many 3's do we actually have right here? You can count. There are 7. So instead of writing these two separate powers, I will write one power. 3 to the 1, 2, 3, 4, 5, 6, 7th power. And that would be the simpler way to write this. Now, if you can write it as a number base within power, we can use a calculator and actually find out what that is. I'll show you how to do this in class when you get back from your vacation. If you don't have a fancy calculator, you just literally do it 7 times. 1, 2, 3, 4, 5, 6, 7. It equals 3 to the 7th power is equal to 2,187. I promise you won't have to type that in all the time. There's a faster way to do it on a scientific calculator. Let's go over to the other example. I have 3 different powers here. 10 squared, 10 times 10, that's what I'm multiplying, is 10. And the exponent is how many times I'm multiplying. Okay, let's go to the next box here. 10 to the 4th power, 10 times 10 times 10 times 10. 4 tens. And finally, the last one is 10 to the 3rd power. There are lots of 10s here, right? Now again, because we have these parentheses right next to each other, they're implying that we're supposed to multiply the purple by the red by the green. But instead of writing it 3 separate times, you could simplify this because they're all multiplying the same base. They're all multiplying 10. So I have how many 10s now? 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the 9th power. And of course, you can use a calculator and do that. 10 to the 9th power. 10 times 10. Well, there's a faster way to do this, isn't there? 10 to the 9th power means that I'm going to have 9 zeros. Think of it. Remember, 10 to the 1st power just has 1 0. So 10 to the 9th power has to be 10 times 10, 9 times. So it'd be 10, 9 zeros. You should know that that is a billion. Okay, let's double check. 10 times 10 times 10, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 billion. Now, instead of having to write them all out like this, all these tens, is there a faster way to do these problems? Have you noticed a pattern? Since these guys had the same base and I was multiplying to combine them, I went from 5 and 2 to 7, 2, 4, and 3 to 9, 2 plus 4 is 6 tens, plus 3 more is 9. 2 plus 4 plus 3 is 9, 5 plus 2 is 9. The rule is, when I multiply same base, you will add the exponents. That's only when you have the same base, the same thing you're multiplying. So I had the 3's and the 10's, and they have the same base. Let's add the exponents. How about this one? Do we have the same base in every single one? I don't think so. We have 2's and 3's. But we could rearrange this because I'm multiplying. It doesn't matter what order I multiply in. So I have 2 to the third times 2 to the fourth. I'm going out of order here. I did these two because they had the same base. I can also do these two because they have the same base. So then the other one will be times 3 to the second times 3 to the fifth. I can combine by adding the exponents. They have the same base. So I have 2 to the seventh times 3 to the seventh. And of course, I can do that in my calculator. 2 to the seventh is 128. 3 to the seventh is 2,187. I can multiply those together, and I get 279,936. All right, let's go to the other one. Let's rearrange these. 4 to the third needs to go with the other 4. There's no exponent on that, though. Well, when there's no exponent, you're assuming it's to the first power. Okay, and then the 5's go together. 5 to the second times 5 to the fourth. Okay, so 4 to the fourth power, because I added the 3 and the 1 because they had the same base. And I multiplied by 5 to the sixth power. 2 plus 4 is 6. Well, 4 to the fourth power is 256. I'm using my calculator to get these numbers, if you're wondering how I'm getting these so fast. And 5 to the sixth power is 15,625. When I multiply those together, I get 4 million. Right on the money. So, the rule is multiply by same base, add exponents. You can rearrange as much as you need to make this work. What if I don't have number bases? What if I have variable bases, like y? Well, same thing. Add the exponents. 5 plus 8 is 13. There's no need to simplify here. If I wrote this up the long way, I'd have 5y's. So that's repeated multiplication. 5y's, and then times 8y's. 1, 2, 3, 4, 5, 6, 7, 8. So that's the purple ones. These are blue ones. I get 13y's when I'm all said and done. How about over here? 2k's, 8k's, 1k. Don't forget that 1 on the exponent here. K to the 11th. We don't know what k was. If I didn't know what k was, I'd use my calculator and evaluate it. Uh-oh. Now we're getting some complicated stuff here. But don't be afraid. This is still just multiplying. If I wrote this out, it'd be 5 times c to the 12th in the first parentheses. In the second parentheses, it's times, again, I use a black dot between these. And then in the blue, it's -2 times c to the third. Now I'll group together the things that are common. For example, the 5 and the -2 are both numbers, so I can multiply those. So 5 times the -2 will go together. And the c's are also common. They have the same base. So I'm going to multiply those together. C to the 12th times c to the 3rd. So now I get something that's not so scary. 5 times negative 2 is negative 10. C to the 12th times c to the 3rd, I have the same base of c, so I'll add the exponents. 12 plus 3 is 15. I keep the base of c. My expression is negative 10 c to the 15th power. Again, another really big one, but don't be afraid. First, write them all out as multiplying. Negative 3 times g to the 2nd power times h, and that's everything in the blue parentheses. I'm going to multiply by positive 7 times g to the what? 1st power times h to the 8th power. That's everything in the orange parentheses. And let's use purple. Now I have times negative 2 times g to the 4th times e to the 9th times h to the 4th. Oops, we can move that. That back up here, no worries. So now, you just multiply what's common. So I'm going to take all the numbers, negative 3, positive 7, negative 2. And I'm going to multiply those together. Negative 3 times positive 7 times negative 2. And I'm going to take all of the g's and multiply them together. There are all the g's there. So I have g to the 2nd times g to the 1st times g to the 4th. Then I take all of the h's together. Multiply those. H to the 1st, h to the 8th, h to the 3rd, and then e to the 9th is all by itself. There's only one of those right here. Now I've covered all my bases. And when you have the same base, you add the exponents. When you multiply numbers, you just multiply them together. Negative 3 times 7 is negative 21. Negative 21 times negative 2 is positive 42. A negative times a negative makes it positive. G to the 2nd, 1st, 4th, 2 plus 1 plus 4 is 7, so g to the 7th. H to the 1, 8, 3, that's 12. And e to the 9th. I don't know why I put 3rd there, it's 9. Okay? And that's my final answer for that expression. What if I take a power to a power? What does that look like? Well, if I have 2 to the 3rd, that's 3 2's. 2 times 2 times 2. And I raise that to the 2nd power, which means this whole base needs to be multiplied by itself again. 2 times 2 times 2 times 2. That's the first one here. Then the second one. Another 3 2's. Right? That's the first base. Second base. How many 2's do I have? 6. What about if I have something else, a different base? Well, that means that I have negative 2x to the 3rd times itself 4 times. Negative 2x to the 3rd, and so on, 4 times, which means I'm going to multiply negative 2 to the 4th, x to the 3rd to the 4th. That means I'm going to have 4 negative 2's, which ends up being a positive 16. And it looks like I'm going to have 12 x's, because x to the 3rd 4 times. Well, last one, 3x squared squared. 3x squared would be 3x times 3x. I have to square that again, so I have 4 3x's. Which means I'm going to have 3 to the 4th power, which is going to be 81, x to the 4th. Okay. The rule for this one is when I have an exponent raised to an exponent, do you notice what the rule was? 3, 2 makes 6. 3, 4 makes 12. Power or exponent to another power means you multiply the exponents. Okay. So I'm going to go through these, but I'm going to run out of time on my video recording because I'm almost at 15 minutes. I want you to try to work these out yourself. Pause the video and then unpause the video and you'll see the answers. Do that now. Pause the video. Do the problems. And there you have them all worked out. If you have questions on this, be sure to message me or leave them in the question box, and I'll see you on Tuesday.